This screencast explains parts of the pollution problem. So the situation is this. We have a firm that produces refrigerators. The firm has two plants. One plant is old and is more costly. The other plant is new and is less costly. How does that work out? Well, let's take a look at this here. So the profits are equal to price times quantity, right? This firm is a profit is a price taker, profit maximizer. So total revenue is price times quantity. So for the old plant, profits are price times quantity old, minus 2 times quantity squared old. So the more stuff you produce, the greater the costs are. And this is a simple cost function, 2 times Q squared. The new plant operates more efficiently. So profits are price times quantity, once again, P times Q new, minus Q squared new. Not 2 times Q squared, but just Q squared, 1 times Q squared. We'll get to the pollution story in a moment. Let's talk about the unconstrained problem. Well, okay, so as in the previous video, which I hope you watched about constrained and unconstrained optimization with the cigars and brandies problem, we've got an exogenous variable. Let's suppose we've got an unconstrained problem, and we've got a table which can describe what's going on. Okay, so price is 800. Quantity old is, well, let's make this 1 and this 1, okay, and we're going to work out profit. Profits in the old plant, profits in the new plant, okay, and total profit. So we've got lots of names here, right? So price, well, that's just price, but you can see it's named up here. Quantity old, that's quantity old, and you can see that the name boxes are changing here. Profit, well, that's just price times Q old minus 2 times Q old squared as before. Profit here, same. Total profit, the sum of the two. Makes sense. Okay, so now we can produce a table, and we've named the column quantity old, and this column quantity new, and we've got price times quantity old plus etc. So we've got the profit function. So here, this refers to, because we're in row 13, it refers to quantity old 250, and in column I, quantity new 100. Okay, so we can describe this, and it's kind of a pretty flat profit function. We want to be somewhere up here, and we can solve the problem. Let's go to solver. All right, so solver looks like this. Okay, so we're maximizing total profit, that's this thing here, by changing C5 and C6. Let's see, so C5 and C6 are Q. We hit solve, and we get a solution which says, okay, and we go back to the previous sheet, which is a disaster. Okay, try this again. So we go to solver and solve this problem, and we get answers of 200 and 400, total profit $240,000. Let's check out the constrained problem. Well, first we go back to documentation, okay, and the pollution. Oh wow, the old plant is awful. The pollution in the old plant is equal to 10 times the quantity. Pollution in the new plant is equal to, these are tons of gunk. All right, gunk is, I don't know, some toxic thing. Let's say tons of mercury, which would be horrible. Okay, pollution in the new plant is just equal to quantity that's produced in the new plant. So if we're 200 and 400, that's 2,000 tons of gunk here, 10 times 200, and 400 tons of gunk here. So that's the situation. Pollution's terrible, right? Before environmental concern's an issue, who cares, right? And all we're doing is we're trying to maximize profits here. That should be a pie, right? These should be pies here, but we forgot that. Okay, so we've done all these things. Suppose the government sets a pollution limit. So, for example, the limit could be 150 tons of gunk for the entire firm. So the total pollution by the old plant and the new has got to be less than or equal to 150. So what do we do now? Well, let's go take a look at the constraint sheet. Okay, so how does this work? Well, basically we've got the same setup as before, right? We've got exogenous variables, endogenous variables, exogenous, endogenous, etc. And we can get, just to show you the exact same outcome, right? 200, 400, great, okay? And now we have to take into account the amount of pollution we've got. So here, pollution in the old plant would be 2,000. Pollution in the new plant would be 400. Total pollution, 2,400. Suppose the government limit is 1,000. Well, we've not met the constraint. The constraint is government limit minus total pollution. So therefore, we've got to do something. We've got to cut back, but we're going to cut back in a way which maximizes profits. Subject to the constraint, we're going to go back. We're going to produce a total of output which leads to 1,000 tons of gunk. Subject to that constraint, we want to maximize profits. Okay, so how does our graph work? So take a look at the graph. If we were to change the constraint, so say the government limit was 3,000, we'd find that we have a whole bunch more possibilities open to us in terms of how much we could produce from the old plant and in the new plant. Okay, and so we got this whole table here, and we could probably find the unconstrained profit maximization, right? We could probably get there. So let's try that. All right. So if we go to solver, objective function, maximize profit by changing output, by changing cells C5 and C6, subject to the constraint. Let's check out the constraint. C17's got to be greater than or equal to 0. Well, what's C17? Met the constraint. Right now, the government limit is 3,000, and we have met the constraint because we're only producing 2,400. We're producing 600 less than the amount we can produce. So let's go solve, and we get a solution here, and that is in fact the optimal solution as we saw before. What if our constraint is now, let's say 150? Then we have very few production possibilities. Okay, maybe we'll do 1,000 just to make it a little easier to see the table, see what's going on. Fewer production possibilities, and we're not going to get to that maximum on our in terms of profits. Right? What's the best we can do? Go to solver and hit solver, and it turns out that this thing is the best we can do. We're producing 627.5 tons of gunk from the old plant, and producing 62.7 units of output, and 372.5 tons of gunk in the new plant. Total pollution 1,000. We exactly meet the constraint. This is the best we can do. If you look at the table here, 201,000. And the best in the table we got here is combination 50 and 400. We're a little bit different, right? The table doesn't allow us to do subtle variations like this one, okay? And we're doing a little bit better in terms of profit. So that's this problem. You should think about, you don't have to turn in anything on this. You should think about the last question, which is, how much would you be willing to pay if you had to have permits to produce gunk, right? If you owned a permit, you can produce a ton of gunk. If you own 150 permits, you can produce 150 tons. How much would you pay for that 151st permit? All right, that's a question you should think about. So long for now.